Hi there. In this video, we are solving the 13th numerical from the exercise for the chapter Laws of Motion, which is also the 4th chapter for 11th standard physics. Now, as per the question, we have a marble with mass 2m and it is traveling with a speed of 6 centimeter per second. And then following that marble, we have another marble, but this time with a reduced mass, that is only m, but with double the speed. So the situation is something like this. So we have our larger marble followed by the smaller marble. Since smaller marble ka speed is greater than larger marble, to be specific, it is twice. This marble will eventually catch up to this larger marble and they will collide. And after collision, both the marbles will move, but this time with different speeds. And based on this, we have to calculate the coefficient of restitution for this particular setup. Seems an easy question, and it is. So सबसे पहले let us understand what sort of given data that's been given to us. So as I said, we have been given the masses of the two marbles, that is one with mass 2m and the other with mass m. Second quantity that's been given to us is the speeds, or initial speeds to be specific, of both the masses. So the larger mass has the speed 6 centimeters per second, but for calculation we need it in meters per second, so it is 6 into 10 raised to minus 2 meters per second. And then u2 is the mass of the smaller marble, which is the double of the larger marble. So 6 ka double is 12, so 12 centimeters per second. So 12 into 10 raised to minus 2 meters per second. Now, in terms of the final velocities, we have only information about one, that is the velocity of the larger mass. And in the question, the condition is given that the after collision, the heavier one travels with the average initial speed of 2. So basically, the speed of the larger mass after collision is the average of the speeds of both the masses before the collision. So u1 plus u2 divided by 2. If we were to substitute the values and calculate further, we would get v1 as 9 into 10 raised to meters per second. And now that we have sorted our given data, we just quickly browse through to find section and we have to find coefficient of restitution. And how do we find coefficient of restitution? Well, we know one formula for coefficient of restitution, that is as per the definition. It is the ratio of separating speeds divided by the approaching speeds. In this context, if we were to calculate it, it would be v1 minus v2 divided by u2 minus u1. This is the textual this particular formula is a textbook formula, so I hope you know this formula. So if you look at this particular version of the formula, we have almost all the quantities except for v2. That's not given to us, but we can calculate v2 again by using the principle of conservation of linear momentum, which states that the initial momentum must be equal to the final momentum. So using this particular principle, we will find out the value of v2 and then substitute it to find out the desired coefficient of restitution. At this moment, the question is 90% done. All the deconstruction and the imagination of question is done. All that is left is the solution part. Let's quickly solve it. So the first thing that we do is from formula 2, that is principle of conservation of momentum, we substitute all the given data that's been known to us. So we are substituting initially the masses of the marble, and as you can see from all the sides, I can just simply cut m, and we have substituted the speeds ka value. So v1 is the average, and if we were to solve this further, we would find v2, that is the final speed with which our smaller mass will move after collision, comes out to be 6 into 10 raised to minus 2 meters per second. Okay, so now that we have found the value of v2, now there's no quantity that will stop us from calculating the value of coefficient of restitution using this formula. So we simply say from formula 1, if we substitute the values of the given quantities, so we substitute v1 as 9 into 10 raised to minus 2. That's the given value of v2 as 6 into 10 raised to minus 2, which we have just calculated. And then we substitute the value of respective initial speeds of the masses as well. And if we were to calculate this further, from this we get v is equal to 3 by 6, which is 1 by 2, which in terms of decimal value is 0.5. And that's it. We have the final answer for our desired question. If you want the PDF version of the solution, do check out the description box. With this, I hope this helped you. Thank you. With this, I hope this helped you. Thank you.